Hello, everyone, and welcome to Techie. So, have you ever really stopped to think about it? With just one click, you can pull up a website from halfway across the world or send a message that gets there in an instant. I mean, how does that actually work? How does that simple click cross the entire globe?
Well, it turns out it's not magic at all. It's all thanks to this universal set of rules, a kind of rule book that every single device on the internet agrees to follow. And that rule book is called the TCP/IP model. It's basically the invisible framework that makes sure all our data gets formatted, addressed, and sent the right way online.
Okay, so let's dive in. Here's what we're going to cover today. We'll look at why it's the internet's rulebook, break down its four-layer blueprint, see how data gets packed up for its journey and then unpacked when it arrives. We'll even check out the different delivery services it can use. And finally, why this whole system just works so well. All right, first up, a four-layer blueprint. You know, sending information across the globe is, well, it's a super complex job, right? So to manage all that complexity, the TCP/IP model does something really smart. It doesn't try to do everything at once. Instead, it breaks the entire task down into four distinct layers. Think of it like a high-tech assembly line, where each station has a very specific job to do. So everything kicks off right at the top, at layer 4, the application layer. This is the part you and I actually see and interact with. You know, when you open your web browser or you hit send on an email, that's the application layer in action. It's where the data is first created, using protocols like HTTP for websites or SMTP for email. Okay, so once your data is created, it gets passed down to layer 3, the transport layer. Now, its job is to act like a data manager for the whole trip. It establishes the connection, takes that big chunk of data, and chops it up into smaller pieces. And right here, it has to make a really important decision. Do we need this to be super reliable or super fast? We'll get back to its main protocols, TCP and UDP, in just a little bit. All right, next up is the internet layer, layer 2. And this one is basically the global address system. I mean, think of it like the planet's post office. It takes those data chunks, slops a logical address on them, that's your IP address, and then it figures out the best possible route to get that data across all the different networks to its final destination. And last but not least, we hit layer 1, the link layer. So if the internet layer is the global post office, the link layer is your local delivery driver. This is where the rubber meets the road, literally. It handles the actual physical transmission, turning all that digital data into electrical signals for an Ethernet cable or radio waves for your Wi-Fi. It's all about getting the data from your computer to your router. Okay, so we've got these four layers, but how do they actually pack the data for its trip? Well, as your data moves down through that stack, from application all the way to the link layer, it gets wrapped up step by step. This whole process has a name. It's called encapsulation. And honestly, the best way to picture it is like packing a box to ship overseas. So what exactly is encapsulation? It's pretty simple, actually. As the data goes down through each layer, that layer adds its own little bit of information, a wrapper, called a header. It's like each layer is adding its own shipping label to the box, with special instructions that only its counterpart on the other end can understand. And here's exactly how that works. See, your data starts at the top. The transport layer gets it first, wraps it in a TCP or UDP header, and now it's called a segment. Then that whole segment is handed down to the internet layer, which adds an IP header, and boom, it's now a packet. And for the final step, the link layer adds one last header for the physical address, turning that packet into a frame. Now it's finally ready for its journey. All right, our little package, our frame, has made it all the way across the internet to its destination. So what happens now? Well, the computer on the other end has to unpack it to read the original message. And this whole reverse journey is called, you guessed it, decapsulation. Decapsulation is exactly what it sounds like. It's the unwrapping process. It's the complete reverse of encapsulation. As the data arrives and starts moving up the layers on the receiving computer, each layer reads its specific header, rips it off, and passes the contents up to the next layer in the chain. Let's follow it up the ladder. First, the link layer gets the frame and checks the physical address. Looks good? It strips its header off and passes the packet up. Next, the internet layer gets the packet and checks the IP address. Is this for me? Yep. So it removes its header and sends the segment on its way. Finally, the transport layer reads its header to figure out which application needs this data, like your browser, and passes the original, completely unwrapped data up to the application layer. And just like that, the web page appears on your screen. Okay, let's circle back for a second.
Remember that big decision I mentioned at the transport layer? The one about choosing how to send the data? Well, this choice really boils down to one simple question. Do you need reliability or do you need speed? And the two delivery services it chooses between are called TCP and UDP.
And this is such a great example of a classic engineering trade-off. On one side, you've got TCP. TCP is like making a reliable phone call. First, you establish a connection. Hello, can you hear me? And then you make sure every single word is understood. If a piece of data, a packet, gets lost, TCP makes sure it gets sent again. This is absolutely critical for things like email or file transfers where you need every single bit to be perfect. But then you have UDP. UDP is more like sending a quick postcard. You just write it and drop it in the mail. No connection, no confirmation. It's way faster because there's less overhead, which is perfect for things like video streaming or online gaming, where a lost frame here or there isn't a disaster, but lag absolutely is.
So this all leads to the big why, right? Why all this complexity? Why have 4 separate layers? Why not just one big protocol to handle everything? And the answer to that question is really the secret sauce of the entire internet. It's the power of this layered model. This layered approach gives us some incredible benefits. First up, standardization. It means any device made by anyone, anywhere in the world, can talk to any other device. It's a universal language. Then there's modularity, and this one is huge. It means we can completely revolutionize Wi-Fi at the link layer without touching how web browsers work at the application layer. This lets the internet evolve constantly. That modularity leads directly to scalability. It's the reason the internet could grow from a tiny academic project into the global beast it is today. And finally, troubleshooting. When things go wrong, and they do, network engineers can pinpoint the problem to a specific layer, which makes fixing it so much easier.
So when you boil it all down, that's the key takeaway here. The real genius of TCP/IP isn't just one protocol or another. It's the whole structured, layered system. It's this brilliant blueprint that provides the foundation for billions of different devices to connect and communicate with each other, totally seamlessly. So hopefully this helped clear up some of the magic behind the internet's rulebook. If you enjoyed this explainer, go ahead and hit that like button. It really helps us out. And of course, subscribe to Techie so you don't miss our next one. We also really want to hear from you. Got any questions? Or is there another tech topic you're curious about? Let us know down in the comments. And that leaves us with one final big question to think about. The TCP/IP model is, it's decades old. It was designed for a very different internet. Now, as our world is evolving with AI and the Internet of Things, connecting billions and billions of new devices, what do you think the next rulebook for the internet is going to look like? Something to think about. Thanks for watching.